Today we're going to look at section 4.7a, completing the square. Our objective is to be able to complete the square to solve a quadratic equation. So what does it mean to complete the square? Well, our goal is to find a constant that will allow you to factor the trinomial as a perfect square. So what we want to do is come up with some sort of constant, some number, that when I put it into our trinomial, I will get a perfect square, which is a binomial times a binomial for our purposes. So kind of show you graphically what that means. X squared can be represented as a square, x by x, to get x squared as an area. Bx can be represented by a square that has a width of b and a length of x, so we get bx. When we say complete the square, it's the exact same thing as actually making a full square if we think about it geometrically. So if I take x squared, and if I take this bx rectangle, and I break it in half, I get b divided by 2 as my width, and I'm going to take that and put that on the bottom. So what I get is an x plus b over 2 for the top and x plus b over 2 on the bottom, but I'm missing this tiny little square at the bottom. Well, what would this square be? This square would have dimensions of b over 2 and b over 2, which the area would be b over 2 squared. That is what we need to complete our square. We're going to look at the lead coefficient for our x term, our b value. We're going to cut that in half and then square it, and that number will complete the square for us. So this is just a geometric representation of that. So why would we want to complete the square? Well, when you complete the square, it makes a quadratic easier to solve because if you remember, you guys have solved problems where we have, for example, x plus 1 squared equals 9. When I'm able to complete the square, which makes the trinomial factor into a perfect square, I know I can take the square root of both sides, which makes it easier. And also to put a quadratic into vertex form. In our next section, 4.7b, we're going to talk about when we have a quadratic in a times x minus h squared plus k, which we've already actually graphed these, but now we're going to actually take quadratics from standard form and place them into vertex form. And we need this process of completing the square in order to do that. So let's do some practice problems of actually finding that small missing part to complete the square. So I have x squared plus 6x plus blank. Well, if we look at our model, I'm going to do one just graphically just to show you kind of tied into what we did before. So this is our x and our x, and we have this square that's 6 by x. Okay. Well, what I'm going to do is I'm going to take that x by x square, I'm going to cut this in half, make that a 3 by x, and this is going to be a 3 by x. So what I'm missing is this little square down here to get a perfect square. And this, it just has dimensions of 3 by 3. So this is 3 squared. And 3 squared is 9. But what's an easier way than actually drawing this out each time? Well, if I take my middle term, my b term, and cut it in half, I get 3, and then I can square that to get my missing piece. So let's look over here. If I take my middle term, negative 20, if I cut that in half, I get negative 10. Okay? And if I square that, I get 100. The reason this works is because this will now factor to x minus 10 times x minus 10, which gives me x minus 10 squared. Just as the first example would be x plus 3 times x plus 3, which gives me x plus 3 squared, which now will make problems much easier to solve. But what if my middle term is not even, where dividing it by 2 gives me, a nice integer? There's no problem with that. If I take negative 7 and divide it by 2, I just get negative 7 halves. But remember, that's the dimension of our square, or one of the sides. But I need to square that to get my little area, if I look at this, to complete the square. Well, when you square a fraction, you just square the numerator, which is 49, square the denominator, which is 4. This would factor to x, the nice thing is I'm just going to use this number, minus 7 halves times x minus 7 halves, or I could just write it as x minus 7 halves squared. Same thing here, if I take my middle term 9, divide it by 2. Please don't change this to a decimal. First of all, you're going to have a hard time squaring a decimal without a calculator, and two, it just makes it look a lot nicer and will help you solve it algebraically a little bit better as we go on if you leave it as a fraction. So I take my term, cut it in half, and remember that cutting in half takes this rectangle and just breaks into two smaller rectangles to get to help me complete the square. So I'm going to square this. So if I square 9, I get 81. If I square 2, I get 4. Now this trinomial is a perfect trinomial, perfect square trinomial, which will factor to x plus 9 halves times x plus 9 halves, or x plus 9 halves squared. We're not going to use this to help us solve some problems. So in this case, I have this problem, x squared plus 4x minus 5 equals 0. Now, there's more than one way to solve these, but if I ask you to complete the square, this is what I'm asking you to do. First, you want to look and think, well, if I take my middle term and divide it by 2, I get 2. If I square it, is that the number that's here? Because if it is, it's already done for you, but it's not. So I know this constant right here isn't the number I want. So what I'm going to do first is move it to the other side. So now I'm going to have x squared plus 4x plus blank, because that's like what we did in our last practice problems, equals 5. Okay. But now I need to find that number to go on that blank. Remember, it's just take this number, divide it by 2, and then square it. Well, half of 4 is 2. 2 squared is 4. But I can't just add 4 to the problem. Okay, if I have an equation, remember I need to balance my equation. So if I add 4 to one side, I have to add 4 to the other side. Okay, to still making an equivalent statement. So now on the left-hand side, I know this is going to factor to x plus 2 times x plus 2. Okay, because 4 divided by 2 is 2, a positive 2, so I know that's my number inside, equals 9. And now I'm just going to solve. The easiest thing to do is to take the square root of both sides. So I get x plus 2 equals, and remember, be careful, plus or minus 3. Now I'm going to subtract 2, and I'm going to get 2 answers. A positive 3 minus 2 is 1. A negative 3 minus 2 is a negative 5. And I can take both of these answers and substitute it back into the original equation to make sure it works. Let's try another one. Again, if I take half of my middle term, that's negative 6. If I square negative 6, I do not get 7. So I know that is not the constant I want there. So I'm going to move that over. I'm going to get x squared minus 12x plus some number is going to equal negative 7. And now from my last example, I know I'm going to have to add that same number to both sides. Well, I know half of negative 12 is negative 6. And if I square that, I'm going to add 36 to this side, which means I'm going to add 36 to the other side. Now I'm going to get x squared minus, x, not x squared, x minus 6 quantity squared. That's what this factors down to, equals negative 7 plus 36 is going to give me a 29. Okay. Now what I want to do is take the square root of both sides. X minus 6 equals plus or minus. Now the square root of 29 does not simplify anymore. If it did, I wouldn't want a decimal answer. I'd want a simplified radical. And then I'm going to add 6 to both sides. Because these are not like terms, I can't combine them. So I'm just going to write 6 plus or minus root 29. And it's pretty standard to put the plus or minus in the middle, so we always put the radical at the end and our constant in the front. So what do we do if we don't have a lead coefficient that's a 1, if we have something other than 1? Because right now, we've talked about the square that has x squared, but now I have a 2x squared. So there's a couple of things you can do. The first thing we can do is if your lead coefficient goes into each of them, I would just divide everything by 2 right away to make my life a lot easier. So now I'm going to start with x squared plus 8x plus 2 equals 0. Now you can solve it like you did every other problem. First thing I want to do, half of 8 is 4, 4 squared is 16, so I know that this number should be on the other side. So I'm going to get x squared plus 8x plus blank equals, make sure when you move something to the other side you change the sign, so negative 2 plus blank. Okay. Half of 8 is 4, 4 squared is 16. If I add 16 to one side, I have to add it to the other. Okay. So now what I'm going to get is x plus 4 quantity squared, because that's what x squared plus 8x plus 16 factors to. Negative 2 plus 16 is 14. And take the square root of both sides. And then I'm going to get x plus 4 equals plus or minus the square root of 14. Again, this doesn't simplify anymore. subtract 4 from both sides, and then I get a final answer of x equals negative 4 plus or minus the square root of 14. Okay. All right, so now I have a number as well. I have a 3. Okay, but 3 goes into 30 but doesn't go into 1. There's still no problem with that, and there's lots of ways to go about these, but I'm still going to just divide everything by 3. Because remember, this value I'm going to move over to the other side anyway, so it doesn't end up affecting the problem that much. So I'm going to be left with x squared plus 10x plus 1/3 equals 0. Okay, again, I know that if I take this number divided by 2 and squared, I don't get 1/3, so I'm going to move this over. So now I'm going to get x squared plus 10x plus blank is equal to a negative 1/3 plus blank. So I know half of 10 is 5. If I square 5, I get 25. So I'm going to add 25 to both sides. So this is going to break down to an x plus 5 quantity squared equals. Now I want to add these two together. Okay, remember to add fractions, they have to have a common denominator. So this is a negative 1/3 plus, if I put a 3 in the denominator, I need 75 in the numerator. So this is 74 over 3. So what I want to do is take the square root of both sides. Okay, so let's get a different color. Take the square root of both sides. So I'm going to get x plus 5 is equal to plus or minus. Now, 74 divided by 3 doesn't simplify very nicely. And if I want to simplify the square root of 74 separately from the square root of 3, okay, because 74 doesn't have a perfect square, nothing I can simplify. But remember, we can't have a radical in the denominator. So what I want to do is multiply the numerator and denominator by root 3. So this is going to give me plus or minus. Okay. I have a 3 in the denominator, and in a numerator now, 222. And I know that doesn't simplify. I can try. There's no perfect squares that go into that. So I'm just going to leave it like that, but I still have to subtract 5 from both sides. So my final answer is going to be x equals negative 5 plus or minus the square root of 222 over 3. So because we had that 1/3, it makes the answer a little bit nastier. And let's try again. Now here, when I divide by 4, or I'm sorry, divide by a negative 4, more accurately. Okay, and again, the reason I like to do this is because you want that x squared. When we complete the square, we need a lead coefficient of 1 for that box to work out. Okay, so what I'm going to get when I do this is a positive x squared, and you always want your x squared positive. Now this is not going to simplify to an integer, but I know a 2 can go into both, and it's now going to turn negative. Negative 9 halves x minus 2 equals 0. I'm going to start off the same way. I'm moving the negative 2 over, so I'm going to x squared minus 9 halves x plus blank equals positive 2 now plus blank. So now you might think, okay, how am I possibly going to take a fraction and divide it in half? Remember, dividing a fraction in half is the same thing as multiplying by 1/2. Okay, dividing by 2 is the same as multiplying by 1/2. So if I take negative 9 halves, if I want to divide it by 2, it's the same as multiplying by 1/2. Okay, so that just gives me a negative 9/4. But remember, I have to square it. So the process is the same. It's just a little bit harder because I'm dealing with dividing a fraction in half. But when you divide a fraction in half, you just actually double the denominator, if you notice that. So when I square this, I'm going to get a positive 81 over 16. And I'm going to have to add that to both sides. So now I know that even though you're like, God, there is no way I would know how to factor this. Well, it's the same process. X minus whatever you got when you divided the b by 2, negative 9/4 squared. Because negative 9/4 plus negative 9/4 is negative 9 halves. And if I multiply negative 9/4 times itself, I get 81/16. So that should work out nicely for you. Okay, over here again, I have 81 over 16. Okay, but I need to get common denominators to add them, so my common denominator would be a 16 in this case. So I get 32 over 16 plus 81 over 16, so my common denominator 16 stays, but my numerator becomes a 113. I'm going to take the square root of both sides. Okay, I'm going to get x minus 9 over 4 equals plus or minus. Now when I split these up, because remember, you can rewrite this as the numerator, the square root of the numerator over the square root of the denominator. The numerator does not simplify, but the denominator, nicely enough, becomes a 4. So move this up here for you. My next step would be to, I'm going to rewrite the last step we had. Okay, so my last step would be to add 9/4 to both sides. Okay, so when I do that, I'm going to get x is equal to 9/4 plus or minus root 113 over 4. Okay, and that would be my final answer. Okay. So how do I do that if there's a fraction in front? Now, everyone kind of freaks out when there's a fraction, but remember, we don't like to divide by fractions. We prefer to multiply by the reciprocal. So instead of dividing everything by a half, and I know students still choose to do that, okay, don't divide by 1/2, multiply by 2. You will make a lot less mistakes if you multiply everything by 2 here. So when I multiply 2 times a half, I'm left with x squared minus 2x plus 20 equals 0. Going to do the same thing, x squared minus 2x plus blank equals, subtract the 20, get negative 20 plus blank. Okay. Now I'm going to figure out what goes inside that blank. I'm going to take half of my middle term. Well, half of negative 2 is negative 1, and if I square it, I get a positive 1. Add that to both sides. Okay. Now I'm going to factor this. This would factor down to x minus 1 quantity squared equal negative 20 plus 1 is negative 19. But now I want to take the square root of both sides. And hopefully from our last lesson with complex numbers and imaginary numbers, you recognize that square root of negative 19 is just square root of negative 1 times the square root of 19. Well, the square root of negative 1 is I, and root 19 doesn't simplify. So this is I root 19. So I'm going to add 1. I'm sorry, this should always still have a plus or minus in front of it. So my final answer is going to be an x equals positive 1 plus or minus I root 19. And all that I tells us that at one point we had a square root of a negative number. So hopefully you feel a little bit better.